All right, let's check out example number 3. According to a recent report, 1% of bachelor's degrees in the U.S. are in the fields of math and stats. One recent math graduate believes that this number is incorrect. She has no indication if the actual percentage is more or less than 1%, though. So she just says, I don't think it's 1%. I don't know if it's more or less. So to perform a hypothesis test, it's a boy. He uses a simple, or she. Oh, no, we just changed gender. I don't know. We'll say it's a she. I think we go back to she. She uses a simple random sample of 12,317 recent college graduates for her sample. She finds that the math or stats degrees were earned by 148 graduates. Does this evidence support the belief that the percentage of bachelor's degrees awarded in math and science, math and stats is not 1%? Use a 0.1 level of significance. All right, it's a she. We decided it was a she. So, step 1, we want to determine the null and alternative hypothesis. So remember, the data was saying that 1% of all bachelor's degrees are for math and stats. She says, I don't think that's true. I don't think the proportion is 1%. She doesn't know if it's more or less than. She just knows it's not this. So our null is that it is 1%. All right, step 2. Since we're dealing with proportions and we're only looking at one thing, it is a 1 proportion z-test at alpha is 0.10. Now, we need to make sure we have met all of our conditions. She has a simple random sample. They're independent. She just asks finding out what their degree is in. It's either yes, your degree is in math or stats, or it's not, so that's okay. So we just need to know if her sample size is big enough. So we need to look at NP, and she has a lot of people that she asked. 12,317. 12,317 times 0.01, which is going to be 123.17. And then n times 1 minus p is going to be 12,317. 1 minus 0.01. And that's going to be also fairly large. 12,193.83. Both these numbers are definitely greater than or equal to 5, which was our conditions that needed to be met. So this is okay. She has asked enough people. Her sample size is large enough. All right, do we have room for step 3 down there? Let's see if we can squeeze it in. Step 3, we need to calculate our test statistics. Step 3. So z is going to be p hat minus p over the square root of p 1 minus p over n. All right, p hat, that's what she found from her study. So she found 148, does that sound right? 148 out of the 12,317 minus p, which is 0.01, over square root 0.01 times 0.99 divided by, I apologize for this, the 12,317. You guys can figure this out. You're smart people. Make sure your numerator is in parentheses. All right, if this is terribly bad, you can go look at the PDF notes that are on Google Classroom. You'll be able to see everything I actually wrote. This is the one that has a z-value of 2.25. Okay. All right, so now we need to make some conclusions about what we just talked about. Now remember, this is a two-tailed test. So even though we got 2.25, since it's not equal, we also need to look at negative 2.25. It's a two-tailed test because she wasn't sure if it was greater than or less than, whatever. So we want to know what's the probability of landing in either of those regions. So our p-value is the probability of either being in this region or this one. They're going to be the same, so we can just double it. So it's 2 times the probability of z being less than or equal to negative 2.25. Okay, if you're looking it up in the table, you'll just, it's that table A, you'll look up that negative 2.25, find the area under it, and you're going to double it. If you're your calculator, this is a normal CDF. Your lower bound is negative infinity, upper bound is negative 2.25, mu is 0, standard deviation of 1. Either way, you're going to get something really close to 0.0122. Again, could be a slight difference, whether you use your calculator or the table. And when you double that, you get 0.0244. So this is our p-value. We need to compare our p-value with alpha. And clearly, our p-value is less than alpha. So in that case, we are going to reject the null hypothesis. Okay, if we reject the null hypothesis, her claim is correct, or appears to be correct according to our data. So we would say something like, at the 0.01 level of significance, the data supports that the percentage of bachelor degrees awarded in math and statistics is not 1%. Now remember, she didn't make any claims about if it was more than 1% or less than 1%, so we can't say anything about that. It's just not 1%. So this is how you do proportion hypothesis tests with proportion, if you just have a one proportion. Tomorrow in class, we'll go back over this, make sure you know what's going on, and I'll teach you how to do these in your calculator. There's one little trick that's going to be kind of important there. And you guys can start on the homework for lesson 10.4. Just won't be able to get all the way through it, but you can do that. I will see you tomorrow.